Hello, and welcome to today's episode of Rawkode Live. I'm your host, Rawkode. Today we're going to be taking a look at Q, a language for validating data amongst a whole bunch of other things that we're going to dive into in today's session. Now, before we do that, this is a little bit of housekeeping. First, if you're not already subscribed to the YouTube channel, please feel free to do that now. Click the bell and you'll get notifications for all future episodes. We stream weekly and loads of various cloud native and Kubernetes content. So hopefully worth a subscribe. If you're not watching live, I would encourage you to join our Discord server. There is lots of good conversation and chat around cloud native and Kubernetes in that channel. And we also talk and suggest new tools and technologies to cover on this show. And lastly, I want to thank Equinix Metal. They are my employer, but they very kindly allow me the time and resources to invest in this show, producing cloud native learning materials for us all to learn together. If you want to try Equinix Metal, then you can use the code Rawkode. This will get you $200 of credit. You can spend that very quickly on 50 hours of compute on a beefy instance, or get up to 400 hours of compute on something a little bit more modest. Check it out. Let me know how you get on. Now, today, to dive into Q, I'm joined by its creator and maintainer, Marcel van Lohuizen from the Google team. Hey there, how are you?
Thank you for having me. Good, I'm doing good. Thank you for having me. It's always great to be able to, demonstrate what I've been working on. So appreciate that.
Yeah, I'm really excited. I'm a big fan and almost advocate of Q. I feel like I'm always telling people to go check it out, and I'm really looking forward to this, just kind of having a bit of fun today and showing people how cool of a technology that is.
Cool.
Before we get started, why don't you just take a few minutes to introduce yourself, and then we'll start and tell people what Q is.
Yeah, so I'm Marcel van Lohuizen. I'm employed at Google, been working there for a long time. Was on the founding team of Borg, and started out in the search engine team. And then after a few years, ended up on the Go team, hung out there for a while. And then a couple of years ago, I started working on Q, and to sort of realize some of the vision that we had earlier, really in the early Borg eras, but never got to, if you will. So, and that's how I ended up here, I guess.
Nice, awesome. So I believe you're going to do a little bit of a presentation just to introduce us to Q. I would encourage, if you want to just get your screen ready for that, we can move into that. I would encourage anyone watching to, get your questions and send them over to us. We'd happy to answer them as we go. And there will be a hands-on section afterwards as well.
Yep.
Now you get to play Find a Window, right?
Yeah, I think I'm there already.
Yeah, yes, there we go. Perfect, thank you.
Yeah. So I hope, all right, great. Yeah, so I'll get right to it. So first of all, what is Q used for? So it's really an offspring of GCL. So JSONet itself is an offspring of GCL, but rather than focusing on just data configuration, it really tries to cover the entire configuration space, right? So things that it's been used for is like fact discovery, workflow definition, configuration, data templating, even code generation, policy checking, test generation even. And Istio uses it for OpenAPI generation, for example. So a little bit of the history behind it. So as I mentioned already, I started on I was on part of the initial Borg team. And one of the reasons I ended up there is because I worked in this little project before Borg, which was sort of like Borg, a little project, a little system that I created was like Borg. So already that system had a lot of knowledge in it from how do you deal with configuration. So some of it was experience from before that Google had on like, how do you, what should you not do, especially. But also from my previous employer, we worked there with configurations. There were hundreds of thousands of lines, managed in distributed teams, purely declarative, and was fine, right? So that was a good example of how you could do declarative configuration and how powerful it is, right? And this was basically the idea we wanted to put into Borg as well. So this is what GCL was originally. However, we made some errors with GCL, which made it sort of not possible to realize that original goal anymore, right? So this is one of the things that prompted Q, right? To do it again right? To really get these promises from declarative configuration management. So also a lot of things changed in this time, right? So the Kubernetes team, which is sort of an offspring of Borg, they did their own research in configuration, and they drew their own conclusions, somewhat different, but very valuable lessons to be learned. And I try to also incorporate that in the design of Q, right? And then, of course, also my Go experience, how do you deal with programming languages and languages in general, had a big influence on how it ended up looking now. Definitely looks very different now than if I'd written it 15 years ago. So some of the key takeaways from all this knowledge that went into it, I think by far the biggest one is like never ever use overrides, right? Just don't do it. To qualify a little bit better, like you can have one level of overrides. This was already the conclusion we had before this very early system. But more than one layer, it just gets too complicated, right? And it doesn't matter if you have file overlays or inheritance, just don't do it. The other thing is you really want to separate code from configuration. So this is another thing that went sour in GCL. So there you see that there is actually a lot of computation in GCL in the end. So the problem is here that we thought, you could always separate it by pushing the computation into the binaries, but that's kind of a, too idealistic view, and in practice that doesn't really work. So you have to deal with this reality that on the one hand, you do want to have computation at the configuration layer, but you still really want to separate the two. Something that came in later, more from Brian Grant and folks from the Kubernetes land, is the whole idea that parameterization is even though abstractions can be good, generally parameterization and configuration is bad. So Q so I agree with that, but Q takes a different approach in solving that problem. So one other thing to mention here is that if you look at configuration, how it develops within a company, is that, well, first of all, the best thing is to have no configuration whatsoever, right? Like in the ideal scenario, you have maybe one parameter to tweak and that's it, right? Like you don't tweak anything. So in practice, what happens is that, systems develop, more and more things that you can configure. So at some point, people start pulling it out of the system, then into individual configuration values. So that gets hard to manage. So people start develop systems around it. Ultimately, that is still too inflexible. So people end up with DSLs. And then these DSLs end up being so complicated that people think like, well, if it's so complicated anyway, why don't we put it in code? And you get back to the top, right? And the whole cycle repeats itself again. So if you look at what, this is a phrase taken from cloudgoogle.com describing the whole notion of, configuration as data, or infrastructure as data, rather, is that you do want to be able to record everything in a single version control. So it's kind of nice if your configuration is text. Doing it declaratively has a lot of benefits, especially because it makes the contracts between all the boundaries of your system very clear. So if you think about this clock and like considering all these options, like having something text-based and declarative is still the best option if you can do it well, right? So the problem is, how do we avoid this complexity, right? And this is one of the main aims of Q, to make this simple, right? And do not get into the same trap as many other configuration languages where there's too much computation, too much complexity in general. So, so let us take a big step back, right? Like, what is configuration? So you have templates, data, validation rules, policy, right? And really, if you think about it, all of this is spread across many different components, right? So you can have a person or a team that provides a system, right? The system itself is configured, but then also users of that system can provide additional configuration, right? Which then has to be combined in a certain way. Then also this can come from multiple customers. That system itself might use another system, all of which have configuration that's somehow related to each other, right? And if you try to combine this, it ends up being not that simple, right? So really it looks a little bit like this. Okay, so you have some data that needs to be filled out in templates, and then you have validation rules, but these validation rules only work on concrete data. So you have to make sure that all the templates are filled out in the right order, and this can be across systems. And it just gets this really big mess, right? Very complicated. And this happens at all different levels, right? So combining data. So what happens if you have conflicting values, right? Like how do you override it? Like what's the order? Same thing with rules and data, or like what comes first? What data do we need to evaluate first before we can even apply the rules? What if you can't get the data at all, right? Like how do you deal with incomplete data? You have different sources, JSON schema, OpenAPI, like all this stuff, right? And then to make matters worse, so configuration tends to be a cross-cutting thing, right? Where you really don't have a specific order in which things get combined, right? It really comes in from every different angle, and there's very little control you have over this. And in order to manage that, then people tend to like dumb down their systems or sort of restrict the configuration in a way that reduces the functionality of the system. So how does Q address this, right? So the idea with Q is that, okay, well, let's get a grip on configuration and create some way of dealing with configuration that you actually can throw it all together on one big heap. So, you don't have to worry about the order of application anymore. You just dump it in all one big bag, and Q figures out how to combine it and how to do all the validation and data production. So how does Q do this? So there's a few things that change. So to the user, now everything has to be done declaratively, right? Like a big part of Q is that it unifies rules and data, and like all of this is the same thing, right? So to Q, all these different aspects of configuration are unified into a single space, if you will. So I'll let that sink in for a moment, right? And I'll come back later to what does that exactly mean. But this is basically what Q does. And to the user, what it means is that Q puts some restrictions on what you can do with overrides, right? So you have basically default values, which you can see as an override. So that's one level, but after that, you're done, right? Like once you set something to a specific value, you can never override it. So there it limits you, right? Like more than other systems. On the other hand, it gives you a lot more flexibility in composition, right? So where you want to combine things from different angles, you now can, whereas previously you had to specify a certain order. So this is to the user how things change. So for what the Q, the way it handles this is basically defining a very rigorous model on what configuration is, and then having a logic reasoning engine underneath it, to deal with it. And it sounds very complex, right? But a good analogy about this, and it is actually very complex. But the idea is that this complexity is a complexity for the implementer, for the people that write Q, but it serves to make the life of the users easier, right? Very much like a garbage collector. A garbage collector is very complex to implement, or can be if you do it right. But the whole purpose of it is to make memory management much easier for the user, right? So this is a little bit how you should think of this. Next slides. There we go. So another way to think of Q is, so if you have a spreadsheet, right, like you have all these cells where you can put in formulas and you can refer to other cells. So Q is really like a spreadsheet for JSON, right? Rather than having a matrix, you have your JSON tree, and you take basically individual nodes and express these in terms of other nodes, right? And then there's this logical reasoning engine that helps you execute that, right? So that's really another way to see what it is. So Q is not just a language, it's a whole ecosystem. So there's the Q command, there's all kinds of higher level libraries that allows you to specify workflows. There's all kinds of adapters to translate back and forth to different formats, API generators, policy engines you can build on top of this, right? There's all kinds of tools for injection and how you combine different pieces of data at different levels. There's refactoring tools, formatting. So Q is very much designed for automated generation also. So the language is designed for machine generation and readability. So that's how Q looks like. And when you think of it as a language, right, like coming back to the DSL side of things, when you think of it as a language, so what requirements do you have as a configuration language, right? So people might be aware of the difference between a scripting and a programming language. So a programming language is much more focused on readability, can be a little bit more tedious to write, right? But really the point is that it's correct and that people can read and understand what it does, right? Because a programming language is maintained by multiple people, right? Like sometimes it has to be read again over a long period of time. Even the original author might have forget exactly what it does. So the same thing holds even more for configuration languages, because now it's not only, often it's written by the original team that maintains a piece of software, but very often it is then maintained or changed by somebody outside of that team, right? And the type of people that work on that might not be the people, might not be the same kind of group that is familiar with the original language that product was written in, right? So think of an SRE team, right? You cannot expect them to be, very familiar with every language that all of the systems they maintain is written in, right? So you need to have something that's even more familiar, more readable, and simpler to understand. And this is complicated, right? So this is a little bit what they try to do with Go, right? And the whole idea is that simplicity is complicated, and it is, but ultimately it makes life of everybody easier. So what does Q look like? So I mentioned already before that Q unifies types and values and constraints, policy, validation. It's all the same thing. So if you look at the bottom, you basically have in this Moscow entry, you basically have JSON with syntactic sugar, right? Like if you squint your eyes a little bit, it's just JSON. You have key value pairs. So if you look at the top, it looks more like a Go struct, right? Like you have the name of the struct, you have the fields, and then the types, right? So in the middle, you see something that is smack in the middle of these two. So you have a large capital. So the name is, again, a string. A capital is now set to true, fixed to true, and population is set to be greater than 5 million, right? So here you see this whole spreadsheet analogy coming back as well. And really, you can mix and match concrete values with types, with constraints, however much you want within Q. Then Q is also aspect oriented. So what that means, so one way to view Q as well. So remember that I said it's just sort of a spreadsheet for JSON. So if you generalize JSON, or if you want to see what JSON really is, right? Like you can see it as a tree of data. But another way to view it is a path with some concrete value at the end of that path, right? And then a sequence of that. So it's basically a sequence of path value pairs, right? And basically what you can do in Q is the value doesn't have to be a concrete value. It can be any type, but also the path doesn't have to be a single path. It can be any group of paths, right? So for example, if you look at this last name example here, so we can say last name is Jones. So you have the path and a concrete value. I can say the last name is a string, which means it's of a certain type. I can also say it's of a type, of a certain subset of strings, namely any string that starts with a capital letter, which doesn't even work for my last name, but it's just an example. But what you can also say is that every field that ends with name, right, I wanted to start with a capital letter. So here you see a group of paths combined into assigned a single type. So now so first of all, let me ask if there's any questions or if this was clear. I'll stop sharing.
Yeah, it was definitely very clear. I mean, you also gave me, the fear that I've been doing configuration wrong my entire life. But, I think there's a lot of, wisdom in those slides, and really you articulated the problem that we have very well, and how hopefully Q is going to come in here and kind of help us do this all better. So that was really great. Actually, even while you were talking, I was tweeting. I loved that line that inheritance is questionable in programming, but it's fatal in configuration. Like, I just think that was perfect.
Yeah. I mean, in Go, you see they're already starting moving away from this. I mean, it has inheritance, just no subtype inheritance, right? But another way to see it with inheritance, so one of the critiques of Q is that people say, well, this is too complicated for software engineers because they're used to inheritance, just use inheritance, right? So maybe that's true, but for anybody that's not a software engineer, inheritance itself is kind of crazy, right? Because basically what you're saying is, okay, let's say we have a cat, right? And now we want to create a dog. So, okay, let's inherit from cat because they're kind of similar. They both have 4 legs and stuff. So we just override a cat and say the nose is now wet instead of dry, and it barks instead of meows. So now we have a dog, right? So to any normal human, that would be absolutely insane, right? And it kind of is, right? So the way you solve it in Q is to say, like, okay, you cannot have a dog inherit from cats. You create an animal, right? You can still have a hierarchy, right? But you create a mammal, right? And then you have a cat and dog instance of that, right? You make it always more specific. Everything you do is making everything more specific. And that's really the basis of it. Yeah.
Awesome. I think one of your friends and maintainers has joined us. Paul Jolly says Q sounds like fun. Hey, Paul.
Yeah.
And yeah, no, we have no questions right now. So why don't we dive into the demo? Again, if you're watching and you have questions that you want us to answer, please drop them into the chat and we will get right on to that. I will pop your screen up with the code.
Yeah.
There you go. Take it away.
Yeah. So I just wanted to give a little feel here for what it means. You can just dump things together, right, with Q. So here I have a little directory with, nope, wrong directory. Good thing I checked. So here I have a little directory with a bunch of files. And so let's look at a.json and b.yaml. So here you see 2 files. They both define a restaurant, top level restaurant map with, name, like basically a name of a restaurant and then some structs describing the restaurant, right? So if I do Q export a.json, pretty much get what I saw there, right? Then I can combine it with the YAML one, and basically, well, let's do the output in YAML, a little bit shorter. Demo effect. All right. My Go heritage, still not used to this. So basically what you see is it combined these fine into a single map, right? Because there's basically no overlap and everything is fine. So this provides you a way of combining, like JSON, YAML, whatever you want. So now the next question is, if I look at, for example, I have another file here. So what if I combine these 2 files? So what would happen? Right, so let me do that. a.json, e.json. So basically what happens, it complains. And it complains because it's the same restaurant with the same key, but they both define this cuisine field, right, with a different value. And Q basically says you cannot do that, right? Like that's the cat and the dog issue again. So basically it says resolve this, right? Like I cannot resolve this. So another thing you can do, so let me open so the schema here. So another thing you can do is apply schema. So here I have a JSON schema written in YAML. So what I like to do with JSON schema, because I find it kind of hard to read, I can basically turn it into a Q schema. So Q reads JSON schema natively. It uses this schema definition and some other clues to figure that out. And this is essentially how the queue looks like. So I have a top level restaurant map, and then which is of type restaurant. There's the cuisine and a list of tables, which basically describes like how many seats and whether it has a view or not. So very, very simple schema. So now I can use the schema to verify if my values were correct, right? So I can do it with a.schema was a correct restaurant, b.schema was correct. But now I have here, so let me open it first. So I have a code, was it this one? I think so. So here I have another YAML thingy. So I can do a vet, so I don't want to see the output, I just want to validate if it's correct. So I can run it, and now I get a error, which is correct, because if I look here, right, the maximum is 10, so here I have 12. So if I fix that and run it again, so that's fixed, but now I have another problem. So this is what's called an incomplete problem. That's why I wasn't showing it immediately. So the other was a hard violation, but now it's something that could have been solved if I provided more information. So the problem here is, if you see that seats is actually a required attribute, but it's not specified for the last item here, right? And really the problem was that there was an extra dash. That's really what was going on here. So if I run it now, it's fine, right? So similarly, if I so open, for example, another schema here, let's open the so let's open the already had that. So let's say I have these two schemas, right? And so one is an older version of the other. So let me run this again. So here you see the queue is a little bit easier to read. So if I now combine that with the later schema I had, so what you see is the old schema basically said the seats, every table seats at least 4 people and at most 12. Their newer schema, like, they like to have a little bit more space. So it says, it seats maximum 10, minimum 2. So if I combine these schema, it takes the intersection of that, and it's greater than 4, smaller than 10, right? Like, you can use this to also check backwards compatibility of schema and all these kind of things. So let me move to a next demo here. So open these files again. So one thing that makes Q work very well, and this was already a realization that 20 years ago in sort of the ancestor formalism that Q uses, is that if you have a schema validation, to have codes. So can I do 2 things at the same time? So if you have a schema for something that really also at the same time is a template, right, that you can use to reduce boilerplate. Really, these 2 things, if you have to write formalism, these 2 are the same things. So so one common use case for Q is that you say, okay, we start out with this whole bunch of JSON or YAML, whatever you have, right? And now we first want to check if it's actually correct. So what you do is you start with the schema to sort of that captures the rules and sort of your understanding of what all this code is. And then you start to run this against your YAML and JSON and see if it's actually, is the way you thought it was. And then very often you find tons of errors, right? The first time I started applying this to my own JSON, I found, and YAML, I found tons of errors. And then once you've eliminated all these errors, you can use the same schema to then say, like, well, now I actually want this to be, like reducing boilerplate, right? So it basically does 2 things at the same time. So let's see what's going on here. So what you see here is not Kubernetes. It's a simplified form of it. So it actually, fits within one window here. But it's similar. So what we have is, I can say I have a map of deployments keyed by their name, right? I say the kind is always deployment. Their name is always the same as the key. So replicas, I have a small server, so usually I only have 1, right? So that would be the default, but it can be any integer. So there must be an image, right, of string, and I have a few selectors where I say, can be more than that, but at least the app should always be the same as the name. And then env, I now hardwire to prod. Could be, one of a choice of a few things, right? But for now, I hardwire it. So same thing, we have a service doing something very similar. And then here, this is an interesting one. So in this setup, let's assume that for every deployment, we have a single service, right? And so what I'm basically saying here is that for every deployment, and the way this comprehension works is that this is like a yield, right? Like the final curly brace is a yield, and that just gets dumped in at the configuration at that point. So basically what I'm saying is that for every deployment that we have, there exists a service with the same name, which has the same selectors, and then, like has a port, the same as the port that's defined in the deployment. We don't require this port here, but this implicitly assumes it's there. So, so the first thing we can do now is we can say, well, let's see if this even works, right? So actually, because I use a package here at the top, I don't have to mention the files anymore. So let's not do that. So the package basically makes them combine all together. So let's run vet, and it gives 2 errors here. And it basically says at trim line 8, column 12, which is here, it says I'm finding 1, right, which is of type string, which doesn't match integer. So I'm getting 2 errors, because if you look at the schema at the respective places, the problem here is that replicas is an integer, but it has 2 values, right? Like integer, the type, and the concrete value. Could be simplified, I guess, by recognizing, focusing on the integer part first. But it found the error. So let's fix that error and then see if we're good now. And yes, we're good. So this is very typical, right? Like you might think you have no errors in your configuration, but you'll be surprised. So now I said, like, okay, now I want to use this as a template, right? So how do you do that? Like, well, first of all, I can do an export on both, right? As I did before, and you basically see I'm getting this full configuration. So you see the ports are there. So, it's exactly as I was expecting here. So now, now I know that I can remove a lot of these fields here, right? So I see kinds, all these things. I want to basically remove those and get the same results. Well, if I want to remove them, that's just simple logic, right? So why would you do that by hand? So there's this command for it called qtrim. So I'll run that now. Then what you see, it has removed here all the fields of my configuration that can be inferred from my validation template, right? And then if I run qexport again, I'm getting the same results, right? Because essentially it only removes the things that could be derived from this template. So I'll have another little demo of where Q is heading in the future. But for now, I'll hand it back over to David.
Thank you. That was awesome. I've not played with trim, but that's a very cool tool there as well. And just a nice, good overview of some of the basics of Q. So we did get a couple of questions, so I'll try and throw them at you now, and then we'll dive into the kind of live component as well. So Kevin asks, still not entirely clear on the trade-off between Q and OPA. Could we maybe discuss that a little bit? There's just a follow-up there. This is actually probably is Q versus Rego. What are the differences?
Yeah, that's a very good question. So basically OPA is, or I don't know how you pronounce these, the OPA, or is it OPA?
According to the docs, it's OPA. Yeah.
OPA. So that means grandfather in Dutch, just so you know. So anyway, so OPA is more of a product, right? Whereas Q is more of a technology. So there is no equivalent of OPA for Q per se, right? What you could do is, instead of using Rego, right, like basically rig OPA to use Q instead of Rego, right? And that would work. So Rego is more mature, right? It's a further developed language. So there's certain, we did recently a lot of research in Q and using it for policy in several contexts actually. And there's a few, tiny features that are missing to make it really powerful for for validation and policy checking. So you can expect more than for normal data templating. You can expect more rough edges with Q using it, right? On the other hand, so if you see where Q is coming from, right, the class of languages where Q is coming up from versus Rego. So there was this well, I wouldn't call it battle, but it's the same people that wrote Prolog basically that went to develop sort of the successor to it that fed into Q, right? But Rego is basically based on Datalog, which looks very much like Prolog, right? But when it came to configuration, it turned out that Prolog really didn't scale. And this is not from a performance perspective. It's just hard to understand, right? It was hard to combine the schema. So basically, in the end, for large scale engineering management, right? Like it didn't really work for configuration, right? And then they came up with this graph unification formalism, which was very successful instead, right? And so Q is basically the same thing, right? I believe it's much better suited for configuration than Rego. It's actually designed. So what you want to do in OPA is basically define constraints, right? So Q is optimized for the constraint definition, whereas Rego is in essence a query language, right? But definitely, Rego is more ahead. So it's sort of like, how much do you want to get into the early bandwagon? I mean, we definitely, we're definitely making it a fully fledged policy language, right? So another thing you can see is if you unify all these different domains together. So with Rego, you really only can specify policy, right? Like you wouldn't want to define data or templating in Rego, right? So with Q, you get a solution that covers the entire spectrum. You have to learn less. But the other nice thing about it is because it functions at all levels, you also can go meta on it, right? So you can define schema for your validation, right? So you can define the space of what are valid validations, right? And so this is something you can make it arbitrary meta, basically.
Yeah, I think you've answered that great. I'll just reiterate the bit that I think is really important is that Rego really just does constraints, validation of constraints. Does this document match my constraints? Whereas Q does much.
I love Prolog, don't get me wrong, right? But this is just a purely practical engineering. Yeah. So I see that Bart has a question.
I'm going to pop that up right now. So Bartlome has asked, thank you for the explanation. As we learned, Q is read friendly, but when you configure something, you're writing configuration. So there's lots of edit and write processes involved.
Exactly. Yeah. So definitely we wanted to make it read friendly, even if that meant sometimes making it less write friendly, right? And what we hear from SRE so far, which is almost the polar opposite of GCL, right? Like GCL is very easy to get going. So that would be sort of a JSON equivalent. It's very easy to get going and it'd be very, generating stuff quickly. But it very quickly becomes complicated, right? Like you cannot see where values are coming from. Whereas in Q, it's sort of the opposite, right? Because you have these restrictions, also might very well be because you're not used to not having this inheritance and being able to override, right? So because you have these restrictions, it put a lot of restrictions on how you can organize things, which might be very hard in the beginning, right? So writing it is indeed potentially more complicated than with JSON or GCL or whatever. So we do think it's a matter of getting used to, right? But even I have to get used to it at times, right? But on the other hand, we had this bug in Q a while back, and somebody gave us these hundreds of files of Q, right? Like thousands, many thousands of lines generating. It was not that big, but generating 100,000, 120,000 lines of JSON, basically. But it was still complicated enough. And to prove whether it was a Q bug or a bug in the configuration took about 1 minute, right? We basically could very quickly narrow it down. You could find the two relevant lines in the queue, and you knew that they were just dumping all files together, right? So we just from these two lines, we just knew what the answer had to be, right? Like there's no inheritance chains to follow, nothing, right? Like it was literally 1 minute to figure that out, right? So that's something you just can't forget with GCL basically.
Awesome. All right, we've got one more question, and then we'll get my screen shared for some more live stuff. So Kevin is asking, would or could I use Q to start a code gen pipeline, for example, Q-based service definition to generate gRPC code?
So at the moment, at least within the Q framework, all the generation is custom implemented, right? So you can generate OpenAPI, for example, which is part of the way there. But for anything custom, it's a little bit tricky. So there are some third-party, Accenture usages of Q, where basically they use the Go templating engine. So there's a Go templating engine built in, right, to generate all kinds of stuff, right? So I'm less familiar with that, to be honest. So it's, there's definitely other people that have been working on that. So one of the ideas is that at some point we also have sort of custom generation packages that you can use to make this generation more easily, right, or make it more easy. But for now, this is all hard-coded. But as I said, there are third-party solutions for that I haven't digged in too deeply, to be honest.
There is the ability to generate protobufs, isn't there, I think? Or is that...
It's actually more so for protobuf right now, it's the other way around.
Oh, right, okay.
So we can take proto definitions and turn it into Q. 0.4 alpha also generates proto values, right? But that's something else. But yeah, generating gRPC is very well possible. So the only thing it doesn't do yet, so design suggestions are absolutely welcome, is so the service definitions, right? Like that's not really done natively in Q yet. I mean, of course you can model it in data, but you want to have some native representation for that in Q. There's some proposals for that, but narrowing it down to what people want would be nice.
Cool. We have one comment that's not a question, but I'll pop it up anyway. Anna says, their docs were previously generated by Q and it worked great. Awesome. Despite your initial suspicion. No suspicion. Come on, Anna. But the tooling around it seemed young.
Yeah,
I guess that's fair. Q is young, but it's evolving quickly, and it's doing great things, right?
Yeah.
All right, let's get my screen shared. This is the Q homepage. So if anyone wants to, dabble along and play with the tutorials themselves, so you can find them at qlang.org. We will pop over to the documentation. And I guess we could take a look at a few things. Will we cover some of the language basics from here, and then maybe just try and go a little bit deeper before we finish on your slightly more advanced demonstration?
Yep.
Okay. All right, let's just pop into the tutorial. So I'll just try and trim this. Hey, that's a nice pun for today. I'll trim this based on what you've already kind of shown as well. So I don't think we need to pop into the introduction. And I think you probably covered most of the types in your starter demo. So I guess it's maybe worth mentioning top and bottom. These are things that I think I tripped up on at the start of my Q journey. Do you want to give us a little bit of introduction to those?
So the way Q handles it, that it always can combine something, is it defines this value lattice, if you will, which basically means that any two values you take, whether it's just an integer or an entire configuration, if you combine them, there's always a single unique answer to that. And this is kind of mathematical. You don't really have to know about it too much, but then like the value that everything combines into ultimately is called bottom. And really this shouldn't have been put in the language, right? Like this sort of offensive symbol there. Really, we should have just called it error, make it a built-in where you can pass a message as well, right? And this is still something we want to do, which is easier. Yeah. Is there a specific thing you were tripping over, or this weird symbol?
Yeah, I think it was probably just more the symbols, especially as I started, maybe like writing Q documents, and you'd see something, like this, or I don't know. To me, it just didn't. It wasn't intuitive.
Yeah.
Oh no, that's not it.
Yeah.
I can't even remember.
Yeah,
I
it's
just
that
looked
one.
at it. Yeah.
Yeah.
But I think it confused me at first. It just took a little bit of understanding, and that when I give something to Q, that it is trying to turn it into a concrete value, and then when I started to understand how that was happening and then validating it against my data, I think things started to get a little bit easier. Yeah, I know I'm still very much learning Q. Every day I learn something new, which is great.
We all do. Yeah.
All right, so numbers and strings, those are all covered. We talked about, you mentioned concrete values and closed values and stuff. Should we cover just a little bit about this? Maybe we should create like a little document with a schema to actually explain these values.
Yeah.
So let me do a main.q. Okay, so you've already shown off like we can do something like this, which has a default value. The default values are star based. So I could do this, right? This is valid Q document. Let me get a terminal.
You don't need the outer curly braces, by the way. Just so you know.
I think that's just a nasty habit I've actually
Yeah,
got.
well, it's not necessarily nasty.
Yeah, I don't know why I do that. I think I don't know. So we can do an eval on main.q, and then we see that the name is coming out with David, and we did that. And I think one of the things that I also struggled with when I was first starting with Q, this is going to just be my airing session of all the things I learned the hard way, but is that, you can bring things in. I don't know why I picked John. I really should have picked Marcel. Is that I could bring, there we go. Is that we can bring in new values. And this whole concept of the constraints living next to the actual data that I've got just took a little for me to become more accustomed to. Like to understand that these were unified to give something that I could export. Took a little while for me.
Yeah, the default thing is a bit weird, but and the original formalism that I worked with, so Michael asked if I ever wanted to work with or exposed to description logic. So not specifically many types of logic, and the symbol definitely comes from logic, absolutely. Yeah, so the formalisms I originally worked with did not have these defaults, but for like cloud configuration and many types of configuration, you really do need this. And this is Q's way of cheating. So really, this is one level of this is basically an override, right? So this is an overlay, if you will, but you basically only have one level, plus it's very clearly marked that this value might change, right? So if you see star David and string, you know there might be another value that overrides it. Whereas if you see Marcel, you know that that's it, right? But yeah, that is a bit, but this basically allows us to get away with inheritance and still be able to reduce a lot of boilerplate.
Yeah, and that one level of override just means that I can't then come back in again and change this value because it's already concrete. Is that the right terminology at this stage?
Yeah.
All right, okay.
Yeah, I have two conflicting values. Yeah.
We had a comment from Paul, but I'm not sure if this was maybe related to the gRPC question. So I will just put it on the screen anyway. But Paul is suggesting you can get pretty far using template and using Q's string interpolation, which has the added benefit over Go text template.
Yeah.
Okay.
Yeah, Q has pretty nice multi-line strings. So this is taken from Swift, actually, which is pretty powerful.
Is that these raw strings here?
Yeah, I didn't know I actually already had a tutorial about it. Like, yes, that's it.
Yeah, so we could do description. Was it 1, 2? I've never used this, but this is a long string.
Now you need to close it with 2 hashes also. Yeah. So you don't need the 2 hashes. The 2 hashes basically escape the escape character, right? So you now need, with 2 hashes, you need \# to escape.
Right.
So okay. I think the idea originally comes from Rust, and then Swift modified it.
Yeah, I think Rust does have raw string
looks
literals,
a little bit
which
different
are like this.
Yeah, exactly.
Like that.
It's the same principle, though.
Okay, so we also were taking a look just there at this concept of like a closed structures in general. So why don't we just define like a simple structure and then try and understand the dynamics of what does it mean to be closed or not closed. But Q uses the hash symbol or pound symbol, whatever you call it, to define structs like this. And then those can have any arbitrary properties in it. Again, I could do something like this. Now, what is special about a definition in Q versus like a normal struct? Is there?
It's just really like any Q value, but we conflated a few of the concepts there, which generally is a very bad thing to do. But in this case, I think it was the right choice. So if it starts with a hash, that basically means, so it's a definition that basically means it's recursively closed. But really, if you define an API, it really shouldn't be closed, right? Like you want APIs to be extensible. So basically, the recursive closeness is just for the purpose of error checking. So you can compare it to protobuf. So if you have a proto definition, right, that you convert to Go, and you have an unknown field, right? Like you cannot basically access an unknown field within this generated Go code. That's a compile error. And that's really how you should see structs within Q, right? Even though the proto in theory should allow other fields as well, and it shouldn't be an error if you have an incoming message to get other fields. You do want to have that type checking within your code, right? And this is exactly what a definition does, right? So it's open in principle, but type checked. It signals Q to type check it for like in a closed setting. That's really what this is. So it makes sense.
Okay. Yes, thank you. I think one of the things that also tripped me up and oh no, that didn't do it. Oh, it's export, right? Is it? Yeah. These kind of definitions don't come out the other side, as well as like there's the concept of a private field as well, something like this, which also doesn't come out in the data. I guess what I'm saying is my biggest hurdle was just these two things living side by side, and it just took a little while to get used to. So I guess I'm just trying to make that clear for the people that are watching that these are things that can trip you up, but they work pretty well when you understand it.
Yeah, one obvious thing that's missing from the documentation is sort of an explanation of what all the prefixes mean, right? So there's underscore and hash. So you also see $, which really doesn't mean anything to Q. It's just JSON schema thing. But basically just a short description, like what do these things mean and like why are they there and how should you interpret it, right? That would be very helpful just at the very start.
Yeah. So in your opinion then, like, people have configuration, as a substrate for pretty much all of our applications. We need to be able to configure things regardless if we're deploying to Kubernetes or we're deploying using CloudFormation or any of these Terraform style syntaxes and stuff. Like, is Q something that people should adopt to define the constraints and validate those configurations? Or is the eventual goal just to have Q being the actual config layer 2? Does that make sense?
Yeah, so there's multiple things to it. I think when it comes to pure data specification, I'm not sure if you would want to send Q over the wire per se, right? Like you want something like really dumb and simple, like JSON. Dumb and simple is good here, right? But for yeah, and then also a lot of people don't need to specify more than a few lines of configuration, right? And then they really should do it in whatever they're comfortable with. But anything sort of on top of that, if you start defining constraints or even, as a specifying data, to me, Q is much nicer than YAML, for example, right? Like I have the auto formatting, auto indent, which is kind of hard to do in YAML, right? So for me, it's much nicer to specify data in it, but that shouldn't be a requirement, right, to do. Yeah. But yeah, policy, validation, all that stuff. Yeah.
Okay, I guess we'll cover a few more basic things, and then we'll work our way through the Kubernetes tutorial. So once we have definitions like this, we can begin to use these definitions, like so. And this defines a key called structs, which can have a list of any number of definitions of structs. And I'm already hating myself for the poor naming on this, but we can now say that this is a list which has an object, hopefully I'm not going to mess this up, which has age, and I'm going to get this wrong on purpose, just like you did in your demo. 0. So I believe, be able to run an eval on this, and we should see an error saying that the first value in our list of structs is invalid because the age is the wrong type defined in the definition here. Does that look okay?
Yep.
We'll find out. There we go. Cool. And if I set that to 21, we get our structs at the other end, but if I export that, we can remove all of the private information and just get the raw data. Cool. I didn't mess it up too badly. Is there anything else you think is worth covering from this list before we do the Kubernetes one?
Maybe like disjunctions or bounds.
Yes. Okay, so shall we add a disjunction? So we say that our really terribly named structure here can only have 2 values, and because we're here, we'll do this. So this is what we call a disjunction. I think the vocabulary there kind of threw me at first. Do you want to just talk about that if you don't mind?
Talk about what?
So disjunction, is this from the mathematical concept of the thing here, or does that come from somewhere else?
Yeah, it's basically being able to say something can be an integer or a string or one of 2 values. And because Q, it's a little bit hard to name this construct, right? Because Q unifies types and values. So if it were defined on values, you would call it an enum, right? Yeah. And if it's a programming language type, you would call this a sum type, right? So it really depends on what you use it for. Also, you can use it for if you're looking up in a map and you want that to succeed, you can say this is the default value, or this is if everything goes well, I want to take the map lookup, but if it fails, I want to take a default value. So that's like null coalescing. You can do that too, right? So really, because it unifies everything, it's this one operation for many purposes, which makes it hard to name, right? But disjunction is a very generic name for these kind of things.
Yeah, to be honest, I think all of the challenges I had with Q was pretty much, they were all my fault. Is that I probably didn't spend enough time going through the documentation, looking at the vocabulary, understanding the syntax. I pretty much just started writing Q and using eval and export loops manually, like print line debugging, I guess, in a weird way. And it's not until I see the error, if we set this to David 2 and run that eval, I was just it's not until I seen them that the word disjunction here, I was like, oh, and it just if you've not used that language before, I guess it threw me a little bit. But again, my own fault for not spending enough time in the documentation.
Yeah, it's what I would do, and maybe the terminology, maybe these error messages could be made more earthly, but yeah.
Yeah, so we can fix that, and now we're back to having working. So this pipe symbol, the ability to specify that it can be one of multiple types, one of multiple values, it's a disjunction. Cool. And you also mentioned bounds. Is that just like min and max?
It's simpler thing, but it's an interesting concept, right? That you can say. So you can compare, you have comparators, right? Like in any other language, you can say, A is greater than B. And then if there are 2 different kinds of numbers, it sort of, converts it to the common denominator. So that's allowed. Normally it's pretty strict with types, but with comparators, it's a little bit more permissive. But then you have this concept where you have this unary comparator, right? And then it's really a little bit like a spreadsheet validation field, right? Where you can basically say this value needs to be greater than 3, and you just write greater than 3, right? And then the and symbol is the counterpart of disjunction. So you can specify many validators, right? So you can say this must be greater than 3, and it must be an integer, and it must be smaller than 8 or less than 8. So you can combine many different validators there.
Yeah, in fact, I'll use a real example because it shocked me and amazed me when I first did this. But I'm sure it's so trivial, but I was so happy at the time. But I was working on a DevRel platform to track all of our events that we were going to, and we wanted to store it in YAML, but we wanted to be able to validate it before we tried to build like the static site that came out the other end. And one of the things we had was this concept like of a start date, which I'm just going to make it an int right now because I'll forget how to actually bring in the date time package. But say it's just an int and it's 1, 2, 3, etc. And we have an end date. It's like one of the things I wanted to be able to do is always validate that the end date actually came after the start date. Yep. And it was actually, when I was doing it in Q here is when I realized that it was actually possible to do that. And I'm sure I'll mess up the syntax here, but is it just that?
Yeah.
Yeah. So using Q, we actually have the ability to reference other properties within, I guess, document. I'm not sure if there's another word I should use there, but yeah. We can make references to other values and make sure that they're valid. So here we're saying that the end date must be after the start date, and we can verify that.
So one thing that might trip users up, so if you go back to that, oh yeah, you can, yeah. So don't forget the %, right? Like the and, because otherwise it's int is greater equal to start date, which is in theory a valid Q expression. So we try to catch these problems, right? Because it can never be satisfied, right? Because int will never be concrete, right? But yeah, so just don't forget the %, right? Like that's the.
Yeah, so we have our conditions here. We have it actually failing. So I guess, there we go. So our invalid value is 0 out of bounds, greater than or equal to 1. We can set that to do. And just, you know, it's not been particularly challenging to just kind of write this document. I feel it reads really easy, and I think that's really powerful for people as we're trying to validate this enormous amount of configuration that we have in all of our applications. Cool. I hope that people are as excited by Q as I am. I don't know if I'm just weird that way. But it just, you know, it takes all of these parts of our application that were really difficult or we had to write really cumbersome tests for before and just brings it across a very simple kind of data plane or a config substrate, whatever. Okay, so we're at 3 o'clock. We've got around 30 minutes left. How long do you need for your last demonstration, just roughly?
The 5 minutes.
All right, okay, cool. So let's try and use this now. I think we've shown off just, you know, Q, constraints, junctions, disjunctions, etc. So we'll take a look at this Kubernetes tutorial here. So the goal of this tutorial is to show people how they can simplify their Kubernetes manifest. Would you say that's correct?
Yeah, everything really. So convert, import, manage, validate, simplify, yeah, templatize.
Yeah. Okay, so I'm going to skim this and I'm sure I'm going to miss bits, but let's see. So what do I need to get started here? I guess I need to run the Q mod in it.
Yeah, so you have to, yeah, well, yeah, you can just start in this original directory, right? You don't necessarily have to copy it, but qmod init, yeah.
Okay, do I need the example.com? I'm just trying to.
You don't need to.
No, okay.
It's, yeah, it's not mandatory.
I'll just create an ABC directory. Again, my naming is always on point, but qmod init. And does this trying to, so once you use Q import to grab some YAML files and convert them to Q. So should I just create a very simple Kubernetes deployment?
Yeah, so basically this is based on an existing data set, right? That's being converted. So you would have to copy the data set.
Or do I need the whole thing, or can I just create a deployment? Does it matter?
Yeah, it would be easier to copy get the Git repo.
Yeah, you're right. I shouldn't wing it. Bad things happen when I do that. So let's just clone it into here. I'm sure there's a flag to tell it to ignore that, but I'll just do this. Okay, so what directory was that? Doc tutorial.
So it's in, yeah, you go to doc, yeah, tutorial Kubernetes, and then original, you could do it there, I guess. If you don't mind modifying the repo.
Okay, so Q mod init from here. Will that work okay?
Yep.
Cool, I feel like I've went off a weird path now, but it should be all right. Kubernetes original. Okay, so now we have our Q module stuff here. Nice and simple. We have this directory of services. we want to then import all of our services. Like, so only that path is going to be different.
Yeah, I would go to, are you in services already, or? Yeah, you don't have to actually, doesn't matter. But
okay, so you just want me to import services like so?
no, just CD into services. You don't need to, but it's, before we forget later, like commands assume that you are. Yeah.
Yep. We're importing all of this, so it's just going to be dot. Is that right?
All the subdirectories too. So dots slash dot dot dot.
All right. Okay.
It's like that. Yeah. We import everything. Yes. So what this says basically, so if you go back to the tutorial, we'll do a little shortcut so you can scroll a little bit down for the sake of time. So I think, yeah, if you take that command, I think that should do it.
This one here?
Yeah. So basically, so all the Kubernetes definitions, they're all in this flat space, right? Like you have these YAML files with the dash 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 in between. And what we're doing with this import is that we're putting it in a namespace. So there's some features planned to queue where you don't need to do that. But right now we're basically assigning them each a unique name, basically by grouping them by kind, right? Like deployment or service, and then a name. And then, so we're treating all of it in the same namespace, basically. And that's what this command does. So it derives the name from the kind and the metadata name. And what the -r does, that's interesting. So some of these config maps, so you can run this, for example. Yeah, that should be fine. And then if you look, if you open the file in Mon, so there's a subdirectory in services, there's Mon, yeah. And then Prometheus, and then config map YAML first. So if you look there, there's this, sort of inconspicuous, like a pipe symbol, right? Which really means that what follows is not YAML, it's a string, right? So that basically means like most of the configuration in this file is really treated, it's just one big string, right? Like untyped, not even YAML structured, right? So the -r option searches for these scenarios and then recursively converts that to queue as well. So if you go to the generated queue in config-map.queue, you will see that, like it also converted that into structured queue. And right now it's a let, but you can then manually assign it to a field if you wish. And maybe I'll make that an option so that it does that automatically. And then it has this call to YAML Marshal. And because it's generated, it has these funky numbers to make it unique. But it has this call to YAML Marshal to convert that back into the original YAML string. But basically, it allows you to also recursively validate the YAML within that queue, right? That's what that does.
Yeah, that's almost magic. The fact that it's taken a YAML multi-line string and has kind of interrogated it to see if it is in fact itself more configuration, and then just giving you that back as a queue object.
And this is one of the problems in GCL, right? That it really had only one layer of validation, whereas very often you have these nested configs, and you want to be able to handle that as well, right? Like typing within typing.
Well, I think you've made literally everybody's head explode. So Julian Pavoto saying, wow. Kevin actually said his brain has exploded, and Michael is agreeing. So there's a lot of magic happiness, I think, in the audience seeing that work. That was really cool. And now we've got, this is just queue representation of that entire thing.
Yeah.
Yeah, that's very cool.
So basically recursively import it for all the directories, put it in that directory. So the directory structure of queue, so they all have the same package name. And we might provide other modes. We're sort of looking into what modes people want to have, but a very common pattern we saw is that, you have this directory hierarchy of configuration where basically you want to have the schema and sort of the root config. It can be a subdirectory too, right? But there you specify the schema that applies to all the schema in the subdirectories, right? So think of it as an ACL, right? So your validator that you specify there sort of should apply to everything in the subdirectory, very much like ACL's work or whatever, right? And this is basically how this is set up now. So now you have this one package which crosses an entire directory structure. And the Q module basically is a single hermetic view on all your configuration, right? So it's supposed to be completely closed and fully defining everything what's going on within these directories. So that's the significance of that.
Cool. We had a comment from Anna who's suggesting that Q is a kind of data-focused Nix, which is a quite an interesting way to look at it. Are you familiar with Nixlang as well?
With Nix, yeah, I am familiar with it. Yeah, so it's a nice language, right? Pretty neat language. So I think Nix is more focused on package management, right? It's a more generic. The language itself is more generic, but you can see it has some elements of it where they're focusing on that. So a lot of the more neat configuration languages like DAL and Nix, they do focus more on functional, whereas Q really is more logic language, right? So I think ultimately for configuration, because you have this aspect orientedness, right? Like you can really only solve that with logic and not so much with functional approaches. So it's depends on your use case, but yeah. So Q takes quite a different approach than DAL and Nix, right? For that reason. Not to say that there is other use cases where that can be quite useful.
Yeah, it looks like Kevin and Anna are having a conversation about potentially using Q to validate Nix. I can't keep up with it, but interesting stuff.
Yeah.
Okay, and there's a nice joke from Kevin, actually. Your recursive flag is to de-ugly things. So.
Yeah. Yeah.
That's nice, a nice way to look at it.
Yeah.
All right, so this is, let's see what this tutorial is doing next. So we've imported.
Yeah.
It's telling us that it all looks better.
Yeah, so that's, so create a top level template. Yeah, you can do that. I would skip the validation. It's not that interesting. You should, but yeah. So one thing that's interesting thing to do if you scroll back up.
Oh yeah, sure.
So this is a very good pattern. So I showed you how to, given a template, reduce configuration. So theoretically, so within graph unification is a known algorithm. It's called anti-unification. I could also do the opposite. So given all the like JSON and YAML we have now, like compute the optimal templates that after running a trim would give the most compact configuration, right? Like that's not implemented. But you can, it's actually quite easy to do that by hand. So what you would normally do is to copy one of the templates that's sort of representative for what you want to do, right? Or what that you think this is sort of a typical example of my configuration, copy that to the root, right? And then start stripping anything specific to it and generalizing it, right? If you don't want to do that by hand, then you can do what this cat block is doing. So this basically creates an initial template, which is really a hand modified version of one of the templates, right? So we can do it by hand, but for the sake of saving time, you can also just copy it. So that you don't need to do.
Okay.
You can either copy it and modify by hand, or you can do the cat thing, which already is the sort of the modified version of that.
Okay, so let's grab this and just run this here.
And this, yeah, in the root directory. So in services, don't know if you're in services.
I was in services, yes. We got a Q.Q now.
Yeah. And then, so basically you see this short example that I gave. This is pretty much the same thing, right? Like you have replicas, like there's a few more labels, but it's basically the same thing. Just scroll all the way to the bottom. Oh yeah, no, it's just these two things. So I don't generate services from deployment, but yet I don't do that here yet. But basically I do the same thing, right? So I say match any of the names in the service map, right? And then I basically say, okay, that name should be the same as metadata name. And that's, all these little tricks like that, right? So there's a few of these, yeah.
Yeah, that's the demo you did at the start, right? Where you created a comprehension over one of these and then just added some extra constraints that locked the service and the deployment together, right? Okay.
And the square bracket basically means it's this path selector, right? So the square brackets basically mean match any path of like that I'm writing here, and here it's underscore, so it matches any path in deployment. But you can also say, anything that starts with a capital letter or anything that is ends with something or whatever. And we're working now on an extension where you can even say like matching patterns within the value, right? So you can really do very complicated pattern matching there to select where you want to apply this template. Yeah.
Awesome.
Yeah.
All right. So what's coming up next in this tutorial then? This eval is.
Yeah, you can run that or vet, whatever, and then you run into errors. So this is the idea here that if you write down these validation rules, right, like you very often, so you might run into errors in your configuration, but you also might run into errors in the rules that you've written, right? So I haven't run this demo in a very long time, so. So one of it is that component isn't defined everywhere. So if you go back to the tutorial. So it mentions that.
Yep.
So basically component isn't defined everywhere. So especially in the, so not all subdirectories, not all files and all subdirectories have this defined. So here you see we have a constraint, right? Let's say we always want this component label, but it's actually not specified everywhere. So if you run the code below, we actually create a small cube file in every directory where we define this this component label, right? So that's some shell wizardry that's not specifically Q.
Yeah, I think I got kind of confused when I copied this and just pasted it, but now I actually see what we're doing. We've created just like some constraints to check all of our services and deployments. Okay, and we're expecting them to have a piece of metadata label that is component with a value.
Yeah, and not everybody, not all of the files have that. So
okay, so this is just suggesting that we use some sed magic. Copy this.
Yeah.
And I don't know what happened there.
Oh yeah, it's
no, that's a multi.
Yeah, so it created all these little files.
Yep. But yeah.
Procs. There seemed to be something wrong there. It should be proxy, but either way, so it might run into more problems.
Is that just me failing at copying and pasting? That's what it is, right?
Yeah, I don't know what happened there.
I wonder if when I ran it here, if I potentially broke something. Oh, I think I definitely have.
I can always do it by hand, but you see the directory is called proxy, so I don't know why that's. You can change it to proxy. It's probably a good idea.
I'm trying to work out what I got wrong. And I'm not even getting star.
Maybe it's a shell incompatibility. Who knows?
Oh yeah, I'm running Z shell, which I guess should mostly work. It's not important. I think we kind of covered a lot of cool stuff there.
Yeah.
And I'm worried that my failure to copy and paste has done something very weird there. Especially the one I control C, which was halfway through, like I said. Yeah, I'm not sure. All right, awesome. I will pop that away. And we'll jump over to your last demo and we'll finish up. If anyone has any questions, feel free to jump them into the comment section. And we'll be finishing up in the next 5 to 10 minutes. You looking for your window? Or if you've frozen? Oh no, you're there.
I'm here. So shall I start?
Yeah, I think you said you had just like a 5-minute thing. So we'll finish with that, and then we'll do a quick recap and we'll end it there.
Yeah. The Kubernetes demo is quite long actually, and it shows you a lot of things of that can go wrong, and So the idea is that basically by the end of it, which is like 20 minutes, if you run through the commands, like you see that you reduced the amount of configuration by half, roughly. Or maybe slightly more, slightly less. I don't remember, but it's you know, like this whole repetitive trim thing, like really reduces. And you can see we start with about 1,800 lines, and by the end, it's like considerably less.
And that's just stripping down the boilerplate and making things reusable whenever possible. It cleans things up a lot, definitely. Okay, Julian says he has 1,000 questions. Well, we'll maybe try and answer a couple of them. Feel free to drop them.
So I'll give this one demo first. So yep, it's a clean thing. So let me just run. So what I'm doing here, so this is basically to show that really there's a logic engine behind it. And there, like it really doesn't, you can use Q for things that have otherwise nothing to do with Q. So here I have a piece of Go code which has types and validation code. And what I want to do now is to generate OpenAPI from this, right? So basically the first thing, I have the commands handy, so of course not, okay, fine, I have to do it by hand. Get go local, we have to, current directory, I guess. Let's see if that was the command, I think so. So if I run get go, what it does, basically it analyzes this Go code. So this already works. And then generates this restaurant go gen Q. And what you see here is this nicely documented, Q representation of the Go types in this file. So this is nothing really too spectacular, right? What you can see though is that I also have this validation code defined on table, which has constraints, right? And I would like to have these constraints represented in Q as well. So I love, tinkering with SSA. So what I wrote is this little SSA analyzer. What it does is first tries to identify validation code. And the way it does that is if a code has no side effects and returns an error, it considers it validation code. And then it can see, of course, it's like, well, this is a method on table that validates or takes table as a first argument, either way, right? So this must be something that validates table. And then basically what it does, it runs over all possible paths in the SSA, representation of that code, and tries to find cases where it knows it will return an error, and then sort of logically reasons backwards to get facts from that, right? So let's do that now. And this has been run also on the Istio code base, for which I did some analysis. And I was able to, so just to give you an idea of the coverage, I was able to get 100% of the validation code, right? So the accuracy, both recall and precision, there was 100%, and about 95% of all possible code paths, I was able to determine whether it would return an error or not, right? And the rest sort of was, the code sort of had to give up. So if we look at what this produced, so this was, yes, SSA.Q. This produces something else, and it's so this is only one constraint, right? So this is quite simple, but if you have many constraints, it becomes quite barfy, right? Like you get all these weird, because it's out of a logical negation, it gets this just dump of all kinds of facts. And then basically, if you want to combine that into a single table, right, we now do Q def, which means schema, right? I don't want to get to the concrete data. I want to define a schema. So we can say Q def SSA, and what was the other one? Restaurant go. Now you see we have the same schema documented, right, with the constraints inside now. And then, of course, I can also do out OpenAPI. Then we have that same schema in OpenAPI. So here you can see we have a OpenAPI, like definition of the original Go codes without any further specification from the user, right? So that's what happened here. So this is kind of the thing you can do with this Q ecosystem, right? It's the idea.
Damn. So I just want to make sure I understood that right. That was just random, not random, but that was just Go code where using Q get Go, it was doing static analysis of that code to work out what the constraints were on it from the different functions that interact with the data and then generating the Q constraints.
Yep.
You then merged or unified, I guess would be the correct word, unified the two different Q files and then outputted an OpenAPI schema.
Documented, yes.
Yeah.
That's the idea. This is even though like in my analysis, so I was able to extract these facts for 95% of the code paths, right? Like that doesn't mean it's already implemented, right? Because now you have to translate that to something concrete, and that's doable. But you have hundreds or about 100 or so, like in that order, like different cases and edge cases you have to handle, right? So it's kind of tedious to implement, but it's definitely possible. And also didn't take too long. It runs like within a minute, right? On the Istio code, more like 20 seconds or so. So it's quite excessive to go for all possible code paths, but it's definitely doable.
Yeah, there's just so much magic there. I think I'm actually going to need time to think that one through and understand it. But the applications of that across a whole variety of different code bases is a pretty cool thing. Very exciting.
Yeah.
All right.
Well, you have
sorry,
question. See?
I think everyone is speechless. I don't think we have any more questions. There's not been anything since the magic static analysis stuff. So I think what we'll do is, all of that was great. Thank you so much for taking the time today to join me. Not just introduce us to Q, but show us some stuff that's coming next, and even just getting some of that experience out of your head to understand the why as well. I think it's just been completely invaluable. So thank you very much. I'll let you get back to the rest of your day. If there are any more questions, people can ask them in the YouTube comments. I'll do my best to relay them on or join the Discord, and we'll take it from there. So Marcel, thank you again. Have a great day, and I will speak to you.
Thank you for having me. And,
my pleasure.
Yeah, if anybody has questions, feel free to contact me. GitHub discussions, there's you can ask questions there. That's our main portal for asking questions now. So.
Yep, there are links to all of this in the description of the video, to the Q repository, to Marcel's Twitter, and I think there's even a link to the Q community Slack channel as well. So lots of ways for people to get involved, get in touch. Again, thank you. Have a great day. I'll speak to you soon.
Well, thanks.